Welcome to solverfy.
We're looking at more problems on friction. Consider the diagram shown in the board. We want to determine the magnitude of the force P such that the polar rotates in an anti-clockwise direction. Now, to solve this problem, we must understand that slip is involved. The polar slips on the shaft. Okay, and we also need to determine what we call the friction circle radius. Okay, now and apply equilibrium and solve the resulting equation to get an answer. Let's say to get the friction circle radius is equal to the radius of the shaft, okay, sine is equal to the radius of the shaft sine the angle of kinetic friction phi k, both phi sub k. We don't know this one, so we can apply something what we call we can apply that it is equal to the arctan of the coefficient of kinetic friction, which is given in the question. So when we do this, we are going to arrive at 16.7 degree as that the angle of kinetic friction. We can now apply this into this equation. When we do that, we are going to plug in the radius of the shaft, which is 2 inch. We are going to arrive at 0.58 inch, 0.58 inch as the friction circle radius. Now, having done that, we can now consider equilibrium, but we don't know this arrow, this reactive force that is here. So we can look at something from Pythagoras. We know that if we have a resultant force is equal to the components, okay, sum the square of the components and take the root like this, the y component. Okay, so having known this, you can now go ahead and consider equilibrium in the vertical direction. If we do that, we are going to arrive at the forces there acting minus 20, the 20 IB force plus the vertical component of arrow, so it's equal to 0. So when you solve this one, you're going to arrive at this component to be equal to 20 IB. Now, having gotten this one, we can now consider equilibrium in the horizontal direction. So if we do that, we are going to arrive at these. So the forces there are P minus arrow, the horizontal component is equal to 0, so that we can now have our arrow sub s to be equal to P. Now we can now plug it into that relation I brought earlier, that if we have arrow, the resultant will be, so we already know, okay, arrow, this one is P, so you square it, plus we already know that the vertical component is 20, okay, square it. So if you do that, sorry, if you do that, you have something like this, okay. All right, we can now also consider moment. If we consider moment about O, check the diagram, you will have something like this: P times the radius of of the the radius of the collar is given, plus 20. The radius of the collar is going to, okay, P is going to that perpendicular distance. Then also the 20 IB load is going through that distance as well. Okay, plus our arrow that which is that reactive force, the components inside the root, sum of their squares. So you have this one. They are going through, force is going through a distance. It's actually going through the this radius, which we have found, which we can now equate everything to zero. When you bring out this one, you're going to arrive at P. Sorry, you're going to arrive at 14 point. Okay, 25P, 14.2, 14.25 P minus 612.3 P plus 5730.89 is equal to zero. When you solve this equation and consider the anti-clockwise direction, because you have plus or minus, you take the minus part of it, that sign, you are going to arrive at P to be equal to 13.8 IB. So this is the force.